Have you ever been faced with trying to get to the root cause of an intermittent performance problem with a multi-tier application? If so, you know that efficiently identifying the problem domain without a lot of guesswork and false starts can be a challenge. Let's use a real-world example to demonstrate how Viavi Solutions Observer Apex can eliminate that guesswork and help us to rapidly and efficiently identify not just the problem domain, but the actual root cause. We've created a business group within Observer Apex that allows us to visualize the performance of this multi-tier application. The map shows us that several locations highlighted in yellow and red are seeing degraded or even critically poor performance. Before we start our analysis, let's explain the application architecture and the 3 tiers. Salesforce.com is the web-based front-end tier, which is hosted by Salesforce in their public cloud. HTTP here refers to a third-party Salesforce plugin called QuoteEdge, which is a web-based application with its own web servers in a separate AWS cloud. And TNS Oracle is the back-end database, which is hosted in an on-premises data center. So we have 3 tiers, 2 of which reside in 2 separate cloud environments, and 1 is on-premises. Where do we start? Well, let's start with our user experience scores. These scores clearly show us that we're having performance problems that are manifest across all 3 tiers of this application. Clicking on the score for Salesforce.com shows us that the servers are taking too long to respond to client requests. So are we done? Is that root cause? Do we call Salesforce and tell them that their servers are slow? Not yet. We're only looking at one piece of this puzzle, and so far, we don't know if this is a symptom or root cause. So let's use our workflow to build out the rest of the picture. Clicking on Salesforce.com shows us that we're talking to 2 different servers, and that both are showing obvious signs of poor performance. Let's focus on the first server and see who that server is talking to. Our on-demand application dependency map will paint that picture for us automatically. On the left side of the diagram here, we see 5 Salesforce users talking to this one particular Salesforce server. The lines are all red, meaning that all of these users are feeling this performance problem. To the right of the server, we see that it's talking to 2 QuoteEdge web servers. Those lines are yellow, meaning that these connections are seeing degraded performance. Moving one more tier to the right, the QuoteEdge web servers are talking to several devices and services on the back end, including Oracle. Notice that both QuoteEdge web servers are talking to the same Oracle server, this 72.22 address, and both of them are experiencing issues with those connections. Now, one thing we'll probably all agree on is that back-end performance problems usually don't just go away or get better as you work your way up through the tiers to the front end. We want to understand what's happening on the back end, get those issues understood and resolved first, and then see how that propagates through to the end users. So let's let the workflow take us a layer deeper here. We'll click on one of our yellow lines, then click on the blue drill down arrow and choose Connection Dynamics. This Connection Dynamics summary shows us all of the conversations between that one QuoteEdge web server and the back-end Oracle server. Let's look at one of the problematic conversations. The EUE score of 4.6 tells us that we do have a critical problem, and you notice that in addition to the score, we've also got an automatic identification of the problem domain. This isn't an application, client, or network problem. Our problem is with server delay. In this case, server delay took 3 minutes and 15 seconds of this conversation. So based on that in our bounce chart, let's just turn everything else off and focus on server delay. Here are all of our server responses and the associated measured delays. As we scroll down through the list, we see that one particular response took 30 seconds. There's our problem. We can now hand this information over to the Oracle team and show them the transaction that's throwing their server for a loop. By the way, if you want to give them the packets, we have the packets too. Clicking on this button allows us to save our conversation to a PCAP file. Let's have a look at that capture. As we scroll down through, noting our relative times, there it is, packet number 57. See the jump in relative time from a fraction of a second to over 30 seconds? Won't it be great to hand this to our database team and say, figure out what's happening with packet number 57? And we figured that out without having to analyze the packets. That was done for us in Apex. Let's review what we just accomplished. We started with a complex, multi-vendor, multi-cloud, multi-tier application, and we got right down to one individual server response. We rapidly verified that the problem was real, not just a figment of our users' imaginations. We saw that performance problems existed throughout all tiers, but we pinpointed the back-end tier as the problem domain, and the one Oracle query as root cause. All of this was made possible by leveraging the power of the packets being captured by our Observer Gigastore systems, combined with the analysis and visualization capabilities of Observer Apex. For more information, please visit www.viavisolutions.com/PTV